Dear students, in previous videos, we have seen what do you mean by decision tree, what are the different terminologies involved in the decision tree. When concept is given to you, you should be capable of representing decision tree. But to represent a given concept using decision tree, you should follow a stepwise procedure. For that, you need decision tree algorithm. So in this video, we are going to learn decision tree algorithm. Now there are two algorithms for decision tree. One is a CART and second one is a ID3. Now what is difference between CART and ID3 algorithm? CART is capable of designing only decision tree for binary classification, but you may have a data set which involves multiple classes. Means a data set which is preferring multi-class classification. Then in that case, you should go for which algorithm? ID3 algorithm. So that is the basic difference between the CART and ID3. The one more difference is the attribute selection measure used for CART is Gini index, while the attribute selection measure used for ID3 is the maximum information gain. So in this video, we are going to see ID3 decision tree algorithm. And the concept is recursive induction of a decision tree. Means what? We are going to develop the decision tree from root node to leaf node. So that concept is known as an induction of decision tree. And the process should be repeated recursively. That's why it is known as a recursive induction of decision tree. Now, as I told you, we should start from root node. Now, in root node, we should select a particular attribute from our dataset. Means your dataset is having multiple columns. Each column is representing a feature that is an attribute. Any attribute you can't select randomly. You should select the best attribute. So that selection of best attribute is possible using ASM. That is what the attribute selection measure. Once the root node is obtained based on the available values for root node, again you have to go for the next level division, and which is known as a subtree or subset. And again you have to repeat the same procedure unless and until you are getting all values equal for your subset. Means you have reached to the final node. That is what the leaf node means. When you are having same values, you are not able to classify it again. Means you will stop your classification process there. So you have reached a prediction stage. So these are the steps involved in your decision tree. Now decision tree is also known as a greedy algorithm. Why greedy algorithm? Sometimes what happen, whatever is the first measure, means whatever is the first feature, whatever is the first attribute present in your data set, that you will select as a root. Okay, that's why it is called as a greedy algorithm. But your ID3 is not a greedy algorithm. What it is doing, it is trying to select the root node as a best attribute. Okay, now how we are developing the decision tree from top to bottom, from root node to leaf node. So that is a top down recursive approach. And as you are going to divide your tree into subtrees, as you are going to divide your data set into subsets, it is known as a divide and conquer method. Okay, so the decision tree is applying divide and conquer method. Now, whatever are your attributes that may be numerical, if it is numerical, no conversion is required. But if your attributes are categorical, then you should convert it to discrete values before putting them into your decision tree. So these are all the pre-processing tasks you should do before starting your decision tree. Okay. Now, generally, you are using the information gain as the attribute selection measure. Okay. And for each node, you have to find out the information gain. Now, here you are going for the majority voting. Now, what do you mean by majority voting is? Means there are no further similar values left. Okay. You have found the homogeneous regions. Means the maximum points from your data set are belonging to that region. No samples are left. Then that will be a stop point for your growth of the decision tree. Now, what is the basic algorithm for induction into decision tree? Understand the meaning of term induction. Induction means what? You are going to develop the tree from root node to leaf node. Okay, so that is known as induction. Now, of course, you have to start from the root of the decision tree, and how you will select that one as a best attribute. Okay, and then what you have to find out, the next level node from your root node, that is known as a child node of your root node, that is the descendant of the root node. Okay, and then finally, by repeating this process recursively, you will reach to leaf node. And when you have reached to leaf node, means a prediction has been achieved. Training of your model is done. Okay, now the question comes to your mind, which attribute is the best attribute? How you are going to choose it? That is what your information gain. Now, this is the ID3 algorithm that is used for the recursive induction into decision tree. First, what I want to tell you by stressing is to find out root, to find out the best attribute in our data set. We are obtaining maximum information gain. Means you have to calculate the information gain for every feature of your data set. Out of all the information gain, whichever is maximum, that is the best attribute. Now the information gain is depending on entropy. That's why we need entropy of entire data set, as well as we need entropy of each feature, because we have to take the weighted average. Okay, that weighted average we are subtracting from the entropy of entire data set. We have seen this in previous videos. How we are getting the formula of information gain? The entropy of entire data set. From this value, we are subtracting weighted average of entropy of each feature. Okay, so the first step is to calculate information gain. I need entropy of entire data set. Then what I need? Entropy of each feature present in my data set. Then weighted average of all these features. Then those value will be subtracted from the entropy of entire data set. And I will get the information gain of that feature. In the same way, I will get the information gain for all the features. Okay. And out of those all information gains, the maximum I will select. Then that will become my first root node. Then whatever is attribute available as a root node, it will have some options. It will have some possible values. So those values will act as the descendant of this root node, that are the internal nodes at the next level. Then, as it is a recursive induction, the step 2 and 3 I will repeat unless and until I have divided my tree into subnodes, and I have reached to a stage that the subnodes are having similar labels. Means there is no further subtree division is possible. Then I have reached to the leaf node. Now, sometimes what happens is your decision tree has grown to more depth, and there are some paths which I am never following. Then I should eliminate those paths. I should eliminate the paths reaching to some particular nodes, the nodes which I am never visiting. So that process is known as a pruning, and that we are going to see in upcoming video. But to complete the algorithm, pruning is one of the important step that we should apply before ending our algorithm, and then final decision tree we have to display. So this is the algorithm. ID3 algorithm for selecting node at each level. It is using the maximum information gain. Okay. Now, this is the tree. This is your final tree. But suppose this is the data set on which I want to apply my ID3 algorithm. Now, this is the final class label. So these are the 4 features. Out of these 4 features, now which feature I will select as a root? Which attribute I will select as a best attribute to start my tree from root? So for that purpose, I need the information gain. Okay, but there are some features using which we can select the best attribute. Now, in some algorithms, we can go for random, means randomly any attribute I can select as a best attribute. In some algorithms, I can choose the attribute with smallest number of the possible values so that it will have smallest number of the subtrays. In some cases, I need a maximum number of the subtrays. Then I will go for the attribute which is having the largest number of the possible values. And as I told, in some case, like ID3, I will go for the maximum information gain. As I told you, ID3 uses max gain method for selecting the best attribute, and which we are going to see with example in more detail in upcoming video. Okay, thank you.